Hi, in this video we are going to see about air conditioners and refrigerators. A typical person in modern society may spend up to 90% of each day in indoors. It is not surprising, therefore, that providing a healthy, comfortable indoor environment has become a major factor in our economy. So, to be more precise, air conditioning is the process of treating air in an internal environment to establish and maintain required standards of temperature, humidity, cleanliness, and motion. Most air conditioning systems are used for either humidity comfort or for process control. Air conditioning. It is the process of treating air in an internal environment to establish and maintain required standard of temperature, humidity, cleanliness, and motion. This is how each of these conditions is controlled. Temperature. Air temperature is controlled by heating or cooling the air. Cooling technically means the removal of heat in contrast to heating, the addition of heat. Humidity. Air humidity. The water vapor content of the air is controlled by adding or removing water vapor from the air. Cleanliness. Air cleanliness or air quality is controlled by either filtration, the removal of undesirable contaminants using filter or other devices, or by ventilation. The introduction of outside air into the space which dilutes the concentration of contaminants. Often both filtration and ventilation are used in an installation. Motion. Air motion refers to air velocity and to where the air is distributed. It is controlled by appropriate air distributing equipment. Sound control can be considered an auxiliary function of an air conditioning system, even though the system itself may be the cause of the problem. The air conditioning equipment may produce excessive noise, requiring additional sound attenuating devices as part of the equipment. The above description does not imply that every HVAC system regulates all the conditions described. Air conditioning system used for newer commercial and institutional buildings and luxury apartment houses usually provide year-round control of most or all of the air conditions described. For this reason, it is becoming increasingly popular to call complete HVAC system environmental control systems. Most air conditioning systems are used for either human comfort or for process control. Air conditioning enhances our comfort. Certain ranges of air temperature, humidity, cleanliness, and motion are comfortable, others are not. Air conditioning is also used to provide conditions that some processes require. For example, textile printing and photographic process facilities, as well as computer rooms and medical facilities, require certain air temperature and humidity for successful operation. Components of air conditioning system. Heat always travels from a warmer to a cooler area. Heat must be continuously supplied to air in the rooms. The equipment that furnishes the heat required is called heating system. In order to maintain the room air at a comfortable temperature, this excess heat must be continuously removed from the room. The equipment that removes the excess heat is called a cooling system. An air conditioning system may provide heating, cooling, or both. Its size and complexity may range from a single space heater or window unit for a smaller room to a huge system for a binding complex. Most heating and cooling systems must have the following basic components: a heating source that adds heat to a fluid, a cooling source that removes heat from a fluid, a distribution system to carry the fluid to the rooms to be heated or cooled, equipment for moving the air or water, devices for transferring heat between the fluid and the room. This is the basic components of a hot water heating system. If steam is used in a heating system, the components still work in the same manner, with the exception that a pump is not necessary to move the steam. The pressure of steam accomplishes this. However, when the steam cools at the terminal unit, it condenses into water and may require a condensed pump to return the water to boil. The warmer room air loses its heat to the cold water in the terminal unit. Since the water is now warmed, it must return to the water chiller to be recooled. This is the arrangement of basic components of chilled water cooling system. And this figure shows the arrangement of basic components of a hydronic heating and cooling system. This shows the basic components of an all air heating and cooling system. In summer, air is cooled when it flows over a cooling source, usually a coil of tubing containing a fluid cooled by refrigeration equipments. When the cooled supply air enters the room is cooled. Because a room size is fixed, the same volume of air that enters the room must also exist. This is usually accomplished by return air ducts. The air is then heated or cooled again and recirculated. An outdoor air intake duct may be provided for introducing fresh outdoor air for increased air quality. Similarly, the same volume of air must be exhausted. Provision may be made for cleaning the air with air filter and for humidifying the air. Remote control buttons. The outdoor unit has the other parts of the system like the compressor, air cooled condenser fan and its own motor and is installed outside. The liquid and suction lines of the system have to be laid aside after the outdoor and indoor units are installed in position. The distance between the indoor and outdoor units has to be as small as possible. As this distance increases, the pressure drop in the suction and liquid lines also increases, resulting in reduction of the unit capacity. Since the compressor is remotely installed from the room to be air conditioned, the noise level will be appreciably lower than in case of a room air conditioner. This is the advantage and the reason for opting for the split. Both room and split air conditioners and a typical remote control are shown in the following figure. Here, unitary or package air conditioning system uses equipment where most or all of the basic components have been assembled in factory. Air conditioning and refrigeration shows this in figure. Split air conditioners. In split units, the indoor and outdoor sections of the room air conditioner are separated out into two casings or units. The indoor unit consists of an evaporator coil, evaporator blower with its own separate motor, capillary tube, control panel, air filter, supply and return grills, etc. Refrigeration. A natural heat sink that is used occasionally for cooling water is atmospheric air. In climates where the humidity is extremely low, evaporative cooling of air may reduce both the air and the water temperature low enough so that either can be used for cooling. A refrigeration system extracts heat from a substance at a temperature lower than the ambient and transfer the extracted heat to the atmosphere at a temperature higher than the ambient. A refrigeration system is termed as a heat recovery system and a heat pump. Refrigerants. Refrigerants are heat carrying mediums which during their cycle in the refrigeration system absorbs heat at a lower temperature and discard the heat so absorbed at a higher level. Chlorofluoride carbons are composed of chlorine, fluorine and carbon atoms. Some in this group are R11, R12 and R14. Hydrofluorocarbons are composed of hydrogen, chlorine, fluorine and carbon atoms. A schematic flow diagram showing the basic components of the vapor compression refrigeration system is shown in the following figure. The vapor compression refrigeration system is shown in this block diagram. The refrigerant has returned to its initial state and is now ready to repeat the refrigeration cycle. These are some of the examples of domestic refrigerator, how it works. The block diagram of the refrigeration system. This is the block diagram of a single door domestic refrigeration system. Thank you.